Hi and welcome to Prototype. We'll be solving the problem for LeetCode 141, linked list cycle. Let's get to it. So given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS, or I guess position, is not passed as a parameter. So return true if there is a cycle in the linked list, otherwise return false. All right, so they give the example 3, 2, 0, -4, and then they give one more argument, which is the position argument, and it's telling us that the end of the linked list, so the node with the value -4, is pointing to this representative array, the second element's index, so index of 1, and it points to 2. Okay, so in this case, we want to return true because there is a cycle. All right, let's get to it. So there's a couple ways we could do this. We could just have a set, and then as we traverse along the linked list, we could add the reference into the set, and then if we find the same reference, if the reference already exists in the set, then we know that there's a cycle, and then we can break out of the while loop and then return true. Otherwise, in the case where there is no cycle, we will traverse to the end of the linked list, and then the current pointer would be null. We would break out of the loop and then return false because we've reached the end, because cur is null. There's another way. We could visit every single node and then add a property to each node. Let's call it visited. And then if we reach a node that has the visited property, then we can break out of the loop and then return true that there is a cycle. Otherwise, same as in the previous algorithm method, if we reach the end, if cur is false, then we know that there's no cycle. And if cur is null, there's no cycle, and then we can return false. Let's do that. So we'll need a pointer, initialize it to head, and while cur is a positive value, truthy value, then we will continue traversing along. How do we traverse? Cur is assigned to cur.next is assigned to cur. And what are we doing? At each node, we're adding a visited property. We'll just say it's true. And then we will continue while cur is not null and while the node has not been visited. Okay, and then we can simply return a Boolean expression. Cur is not null. Okay, so what's happening here? If we visit all the nodes, then we'll break out of the loop. If cur is not null, so cur would only be not null in the case where there's a cycle, then we return true. And then in the case where there is no cycle, then cur becomes null, and then this would evaluate to false. So let's run that. Okay, passes the test cases. Let's submit it. And beats apparently 79.76%. And of course, this is a linear solution. We'll be visiting every single node. It's also linear space because we'll be adding a property, even though it's just going to be a property that points to a Boolean value. Technically, we are still adding, using more memory to get to this solution. Is there a better way? Of course there is. How do we do the better way? Okay. To detect a cycle in a linked list, we use 2 pointers, and we say a slow pointer, we initialize that to head, and a fast pointer, and we also initialize that to head. And we're going to be checking if fast is not null and fast.next is not null. And slow advances slowly by moving to the next node, and fast advances quickly by advancing to not the next node, but the next node's next node. And by doing this, we can simply check if slow is the same as fast, then we return true. Otherwise, there won't be a cycle, and then we can just return false. Okay, what is the intuition for this? Let's go through the example. Slow and fast starts at 3. Slow becomes 2. Fast becomes 0. We check, is the next node not null? It is not. One more. Slow becomes 0. And fast becomes 2. Okay. Slow becomes -4. And then fast, not 0, but also -4. And then we will check this. We'll enter this if statement, and then we'll return true. And if there was no cycle, then slow and fast starts at 3. Slow and fast. Check if the next one exists. Yes, it does. Slow and fast. Null. And then we'd break out and we'd return false. Okay, so let's run that and submit. And there we go. So 83.8 apparently. And let's look at this. So also another another linear solution, but we also use constant space in terms of memory because we're only going to be storing 2 references at once. This is a very good, what do you want to call it, trick to know the double pointer, the fast and slow pointer. Very helpful in these linked list questions. It will be coming up, for instance, in linked list cycle 2. But anyway, subscribe to see more. We'll be doing more LeetCode questions in the future. Thank you, and see you next time.